Hello everyone, my research project was on a divisibility property for the Fibonacci sequence. So we're going to zoom into the first column here. So the Fibonacci sequence consists of numbers, and each number is the sum of the two preceding numbers, starting with 1 and 1. So if you do 1 plus 1, it equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, and then the sequence keeps going on from there. We looked at a known divisibility property, which is for every integer n, there are finitely many numbers of the sequence that are divisible by m, and at least one can be found among the first two m numbers of the sequence. So this is presented in table 1. So if you look at m equals 10, it's f of 15, which f of 15 is 610, and 15 is less than 20, so it works for this table. It also works for the larger numbers and the smaller numbers. Based on this well-known property, we came up with 3 questions. The first question was, given integer m, how far in the Fibonacci sequence do we need to search to find two numbers of the sequence divisible by m? The second question was, given integer m, how far in the Fibonacci sequence do we need to search to find r numbers of the sequence divisible by m? The third question was, are there certain integers m such that at least one Fibonacci number divisible by m can be found among the first m numbers of the sequence? So we're going to zoom into the middle column here. The first conjecture was for every integer m, there are finitely many numbers of the sequence that are divisible by m, and at least two can be found among the first 4m numbers of the sequence. So in table 2, you can see that m equals 10, I equals 30, and 30 is less than 40, so it also works for this table. The second conjecture was for every integer m, there are finitely many numbers of the sequence that are divisible by m, and these r can be found among the first two rm numbers of the sequence. For table 3, you can see that m equals 10, I is 45, and 45 is less than 60, so it also works for this table. It also works for table 4 and 5, and as you can see, m equals 10 has a pattern. It's going by 15. So you could find the tables for 6, 7, 8, 9, and so on. The third conjecture was for every integer m, at least one Fibonacci number divisible by m can be found among the first m numbers of the sequence. So if you look at m equals n, it works. And then also m equals 16n works since 8 is doubled. Also, if you look at m equals 12n, also m equals 24n works because it's double of 12. We're going to go to the third column here. This research project was based on this coding. So as you can see, for n in, it's in a range that goes along with the 7,000 Fibonacci numbers, and we did m equals 8n. Also, you can use it for the first two conjectures and the well-known property by removing m equals 8n and writing for m in, and then picking the range that works for the 7,000 Fibonacci numbers. Now on conjecture 3, there is also counterexamples that we discovered. So for 5n, m equals 10 and I equals 15, but 15 isn't less than 10, so it will not work for this property. It also doesn't work for 3n since m equals 3 and I equals 4, and 4 isn't less than 3. Overall, this Fibonacci sequence was a well-known interesting property, and based on the property, we came up with 3 questions, which became conjectures. The future plans for this project is to prove these conjectures and investigate more properties of the sequence. Thank you for watching, and if you have any questions or suggestions, please don't hesitate to contact me. Thank you.